Okay, so we're talking about periodic table review questions. Make sure you have your reference table. We'll need actually the periodic table, but also table S. So periodic table and then table S. The arrangements of elements from left to right on period 4 on the periodic table is based off atomic number. So that is how the whole periodic table is arranged. Which list of elements consists of a metal, a metalloid, and a nonmetal? So here's my terrible drawing again. Down here. So here's our zigzag. So remember, we have metals here. Metals. Then we have metalloid, which are along the zigzag. And then we have nonmetals, which is hydrogen, and all these. Okay, so metals. Lithium is a metal. Sodium is a metal, so that's already wrong. Chromium is a metal, transition metal in the middle. Molybdenum is also a transition metal, so that's not it. Tin is a metal, it's towards the right. Silicon is a metalloid, it's along the zigzag. And copper is, oh my gosh, carbon is above that, which makes it a nonmetal, so that's our answer. Which list includes elements with the most similar chemical properties? Those are in the same group, which are vertical columns. So bromine's in group 17. Gallium is not in group 17. They're in the same period. Chromium is in group 6. Lead is not in group 6. Nope. Oxygen is in group 16. Sulfur's in group 16. So is selenium. That's my answer. The elements in group 2 are classified as, they're all metals. Compared to the atoms of nonmetals in period 3, the atoms of metals in period 3 have, talking about valence electrons or electron shells. So valence electrons, remember, are the outermost. So I'm looking at period 3, we've got 2-8-1, 2-8-2, 2-8-3, all the way up to 2-8-8. So that means that as you go across, you have more and more valence electrons, so metals would have fewer. Why is it not electron shells? Well, notice they all have 1, 2, 3 shells, so that's why that's not the answer. Periods of the same shells, groups have the same valence electrons. Which statement is identifying the element arsenic, which means it's unique to only arsenic. It has an atomic number of 33. Boom, that's it. The fact that it has a melting point of 84 Kelvin and the 8 valence electrons in the ground, all that stuff, other things have that too, but what is unique to only arsenic is that. Which property can be defined as the ability of a substance to be hammered into thin sheets? That means malleability. That's a definition. What does it mean if you are conductive? That means you allow things to flow through, like heat and electricity. Melting point is the temperature at which you have a solid turn into a liquid. Solubility, can something dissolve? At STP, which is normal, standard temperature and pressure, which element is a good conductor of electricity? That is a metal. So let's look to see who is a metal. Chlorine, that's a nonmetal. Iodine, that's a nonmetal. Silver, that's our metal. Sulfur is our nonmetal. So that's our answer. In the formula XF2, the element represented by X can be classified as. Okay, so these kinds of questions always seem to trip up students. So here's what I do. I say, okay, we're going to bond in a 1-to-2 ratio, 1X for every 2 fluorines. So I go to the periodic table, and I see that fluorine has a -1 oxidation state, which means in a compound, and again, we haven't talked about this yet, in a compound, fluorine is going to like to gain 1 electron. But there are 2 of them, right? So the overall charge from fluorine is a -2, -1 taken twice. So how do I get a neutral compound? What would the charge of X have to be in order to have a neutral overall? And that would be X would have to have a +2 charge, because +2 - 2 is 0. So first of all, we need to find a group where there's a +2 charge. If I look, group 1 are all +1s, so that's not our answer. Group 2, hey, that could be our answer. Let's just make sure. Group 1, group 1 and group 2, those are metals. They are not nonmetals, so that is our answer. Which substance cannot be broken down by chemical change, which means the simplest form, which would be an element? Which of these is on the periodic table? Tungsten, excuse me. A sample of an element is malleable and can conduct electricity. So this is a metal. Who's a metal? Tin. Non-metals only. So boron's a metalloid, so goodbye. Lithium's a metal, so goodbye. Carbon's looking good. Ooh, silicon and germanium, those are metalloids. Phosphorus, sulfur, and chlorine, those are all nonmetals. At STP, graphite and diamond are two solid forms of carbon. Which statement explains why these two forms of carbon differ in hardness? These are called allotropes. They have different atomic radii. Nope. They have different molecular structures. That is the answer. So remember, back in our notes, we have a picture of how graphite have the atoms in thin sheets that are easily broken off, whereas, and this is a terrible depiction, but like diamond is interconnected in a network, so that's why it is. Choice 2. How are we doing? Which particle diagram represents an arrangement of F2 or fluorine molecules in a sample of 98K? So fluorine, 98K standard pressure. So first of all, it's F2, so can't be that. It actually takes care of all of them. And also, we'd need to know that this would be in the gas phase, so boom, there it is. Which atom in the ground state has a stable electron configuration, which would mean noble gas? So who is in group 18? That would be neon. An atom of argon in the ground state tends not to bond with an atom of a different element because the argon atom, again, this is unique to group 18. They have 8 valence electrons, which are very stable, and make them not want to bond because they're already good. Who in group 14 is a metalloid? So carbon, nope, that's a metal. Ooh, silicon is along the zigzag, so that's probably our answer. Tin, no, that's way down metal. Lead, way down metal. Which pair of symbols represents a metalloid and a noble gas? So who is along the zigzag? Silicon is, arsenic is, germanium is, and nope. So who is a noble gas? Bismuth is not. Ooh, argon is. There's our answer. Which is a gas at STP? So anybody in group 18, nitrogen, oxygen, fluorine, chlorine, hydrogen. So where is it? Xenon, group 18, noble gas, which is a liquid. There's only 2, so you have to know them: bromine and mercury. And bromine is the nonmetal liquid, and mercury is the metal liquid. Aqueous solutions, which means dissolved in water, of compounds containing element X are blue. So who forms colorful solutions? This is the transition metals, groups 3 through 12. So who's within those? That would be copper. Which ionic compound dissolves in water to form a colored solution? So we're looking for, again, somebody in groups 3 through 12. Calcium's in group 2. Copper is the answer. That's in the transitions. This is in group 1, and this is in group 13. Which is the largest atomic radius? Okay, so I am going to look on table S. You need to go there too. I can't show you on the screen, sorry. Atomic radius is the last column. Potassium is 200 picometers. Rubidium is 215 picometers. Francium, 242 picometers. Cesium, 238. So it's very easy. Which characteristics both generally decrease when elements in the period 3 on the periodic table are considered from left to right? I don't need to memorize this. I can just look at periodic table and table S. Non-metallic properties decrease. So we're going from metals to non-metals. So that's not going to decrease. So it's not 1 and 2. Metallic properties do decrease because we're going from metals to semi-metals, which are sort of, and then we're going to non-metals, which are totally not. Okay, so what decreases? So remember, I said, take a look at somebody at the start, take a look at somebody towards the end. I would avoid group 18 though. Atomic radius for potassium is 419. Bromine, where are you? atomic radius. 117. Ooh, that did decrease. That's probably our answer, but let's just make sure. I'm actually looking at period 4, but the answer should be the same. So I'll look at sodium instead. So sodium has an ionization energy of 496. And then if I were to look not at bromine, but at chlorine, 1251. Hey, that's an increase. So it is the same idea. Which element forms an ion that is larger than its atom? So who gets larger when you lose or gain electrons? So again, you have to gain electrons to become larger. So who has a negative charged ion? Aluminum becomes +3, so that's not it. Chlorine, ooh, that's a -1. There are some positives, but that's the first one. Magnesium is a +2, and sodium is a +1, so it is choice 2. Which statement describes the general trend in electronegativity and atomic radius as elements in period 2 are considered from left to right? So we already know that atomic radius goes down. So it could be either 1 or 3. So now let's take a look. Period 2. So lithium's electronegativity is 1. And fluorine's electronegativity is 4. So that's an increase. So this is a 3. In the ground state, each atom of an element has 2 valence electrons. So it has to be in group 2. I know right away because valence electrons are groups. This element has a lower first ionization energy than calcium. Okay, so ionization energies for calcium is 590. So let's see. Okay, who is in period 3? Group 2. Magnesium. And group 2, period 5 would be strontium. So magnesium's ionization energy is 738, and strontium's, where are you? 38. 549. So it says it has a lower one, so it's got to be the strontium. When the elements in group 1 are considered in order from top to bottom, each successive element has, okay. So group 1, we've got lithium, sodium, potassium, rubidium, cesium, francium. Let's look at melting point. Melting point for lithium is 454. Sodium is 371. Whoops. So it can't be those. Because I already saw that. Now let's talk about boiling point. So lithium's boiling point is 1615. Sodium's is 371. So lower. Which of the following scientists is credited for developing the modern periodic table? Mendeleev. And each of the elements in the main group of the periodic table have the same number of, let's see, each of the elements in a main group of periodic table, group would have valence electrons. Yeah, that's kind of weird. I had to think about it for a second. All right, if you have any questions, please reach out. I might have made a mistake because I'm a human and I don't have my answer key next to me, so I just derived it all right here. So please let me know. Have a great day.